Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another lead code problem, that is partition labels. So it's a medium level question and it's a very popular question, as you can see from the likes. So let's read the problem statement. You are given a string S. We want to partition the string into as many parts as possible so that each letter appears in at most one part, right? We have to partition the string into multiple parts, and if one letter appears in one partition, it cannot appear in the other partitions, right? So note that the partition is done so that after concatenating all the parts in order, the resultant string should be S, and the partition should be done in such a way that after concatenating it should form the original string, right? So return a list of integers representing the size of these parts. So let's see an example to better understand the problem. So here we are given with a string, right? So we can partition this string into three parts. One is of length 9, another is of length 7, and third one is of length 8. So the first one, that is ABABCBACA, the first character A and the last occurrence of A appear in this partition only, right? A does not appear in this partition nor in this partition, right? Similarly with B occurs uh, only in this first partition. B is not there in the second and third partition, right? Similarly D is in the in the second partition. It is not in the first and the third partition, right? So these three partitions are of length 9, 7, 8 respectively. So let's see how we can solve this problem. We will use greedy approach to solve this problem, and in this approach, in this greedy approach, we will be needing an array that we will call the last array, that will store the last occurrence of each letter in the string given. So for example, in this string, the last occurrence of A is 8, right? Last occurrence of B is 5. Last occurrence of C is 7. Similarly, for D is 14. For E is 15. For F is 11. G it's 13. H 16. H 19. I 22. J 23. K 20. And L 21. So we will greedily choose our left justified partition starting from the first index. So for the first index itself, we will choose a partition where the end of the partition ends at last occurrence of A. So the last occurrence of A, we will check our last array. The last occurrence of A is at 8. So we will have our partition starting from the first occurrence of A till the last occurrence of A, that is 8. So the partition is from 0 to 8. So we will have our two variables, anchor and J, that will point to the start and the end of the partition, right? Now we will check. So it might be the case. Now it might be the case that for the next character, suppose B, we might have to increase the length of this partition, right? Or it might be the case that the length of this partition remains unchanged, right? So we have greedily chosen our first partition, and we will check for the next characters. So for B, the last occurrence, we'll check our last array is at 5. So it's smaller. The last index of B is smaller than the last index of already chosen A. So the partition will remain unchanged. Now the next character is A. So we have already chosen for A. For B, we have already seen. For C, the last index of C is 7. So which is smaller than the already chosen last index, that is 8, right? Or we can say that the last index of C is smaller than J, so the partition will remain unchanged, right? Now for B we have already seen, for A we have already chosen, for C we have already seen, and for A we have already chosen this partition for A only. Now our I has reached J, right? So it means we have seen all the characters. So all the characters in this partition have their last occurrence, their first and last occurrence in this partition only, right? So we will have our first partition. So we will add into the list, resultant list. So we have to add the length. So we will do j minus anchor plus 1. So j is pointing to 8. 8 minus 0 plus 1, that is 9. So first partition is of length 9. Now we will change our anchor from 0th location to I plus 1, that is anchor will point to index 9. Now we'll again do it. We will choose our partition greedily with the first character, and the last occurrence of first character, that is D, ends at 14. So we'll have our partition from 9 to 14. So the anchor will point to 9 and J will point to 14. Right now we will check the next character, that is E. So what is the last last occurrence of E? That is 15. So it's greater than J. So we will increase our partition, right? We will increase our partition. Will we change our J to 15, right? Now we will check for F. For F, the last index is 11. So it's smaller than J. We will not change the partition. For E, we have already chosen for E. For G, the last index is at 13, which is smaller than current J. So we will not change it. For D, right? For D also 14, which is less than 15. So we'll not change it. And for E we have already chosen. So now we have the next partition in which all the elements and their first and last occurrence is within this partition only, right? So now the J is pointing to 15, anchor is pointing to 9, and we'll do plus 1, so it will be 7. So the next partition is of length 7, which meets the condition. Now we will move our anchor to I plus 1, that is 16. So anchor will point to 16. And now we will again choose our partition for the first with the first character, greedily with the first character. So now the partition will end at the last occurrence of H, that is at 19. So J will point to 19. Now we will check for the next character, that is I. So the last index of I is at 12, is at 22, which is greater than 19. So we'll increase our partition and we'll change our J from 19 to 22. Right? Now for J, the last occurrence of J is at 23, which is greater than the current J. So we will increase our partition and we will cover the last character J as well. So J will point to 23, right? Now we will check for H. So for H, the last index is 19, which is smaller than J. So the partition will remain unchanged. For K, with 20, which is less than 23, we'll skip. For L, which is 21, last index is 21, so we'll skip. For I, the last index is 22, we'll skip. For J, as we have already chosen for J, and we are end of the string, so this is our third partition. So we will calculate the length. So 23 minus 16 plus 1, that is 8. So the last length is 9 8, and there are three partitions of 9 7 8 that will be added. Now let's see the code part for it. So I have written a Java code here. So I've created a class solution. I have created a function partition labels, which takes the input s and returns the list of integer. I've created a very array last of size 26 because the alphabets, lowercase alphabets, are 26 in numbers, right? And this will store the last occurrence of each character of the string. So for each character of the string we will maintain the last occurrence in this last array. Now we will have our J and anchor starting from 0, that will represent the start and the end of the particular partition. We've initialized our answer list for, and we will start our for loop starting from I equal to 0 until we go, and we'll go till s dot length, right? So we will update the end of the partition that is represented by j with the max of j, or if there is any character whose last occurrence is greater than j, right? So in the particular partition we saw that first we chose for the h the index was 19, and then when for the next character I, whose the last occurrence was at 22, which was greater than the previously chosen j, that is 19, then we incremented the j to 22, right? And when I equal to j, it means we have reached a point which is the end of the partition, or i.e. each characters in this partition have their first and last occurrences in the same partition only, right? And there is no character whose last occurrence is greater than the current j. So we will add in the answer the length of that partition, and we will update our anchor to j plus 1, and we'll return the answer. So let's try to run this solution. So yeah, the test cases are passed, so it means the solution is working fine. So let's talk about the time and space complexity. So as you can see, we are running one for loop for calculating the last index and one for loop for iterating over each character of the string. So we are iterating in the worst case the length of the string, so the time complexity will be big O of n, where n is equal to s dot length. And for the space complexity, as we are maintaining the last array and the list answer list, uh, which will constitute the space complexity of big O of n plus big O of n, which will be in worst case will be big O of n only, where n is the s dot length. So I hope you enjoyed watching this video. If you like this video, please share and subscribe. Thanks for watching. It will keep me motivated to bring more such videos in front of you. Thank you. Bye.